Hello everybody and welcome back to MMO programming, where this is my Steam library again. And look, I'm playing X4. If I could just move it over to my main monitor so you could see it, but no, that's not the point here. The point here is, of course, that we need to finish our initialization, and I actually think that this might end up being a bit of a long episode, because I kind of want to finish entirely our initialization of our connection here, which is going to take a little bit of time. So we need to continue working, of course, on our initialization here. So first things first, we are going to start ourselves up a new thread to listen on. So, because the way that it works is it blocks the current thread that you're on while listening, and we don't want that. So we're just going to make one with a task here. So task.factory.start new. This is going to be an async task because we, of course, want this to be asynchronous, and we want to do something like this. Okay, and then we will simply do that, but I want to have this on the same line, so we'll do that. Okay, so that would work in theory, but this is a lambda expression. This async method lacks await operators. Yeah, of course, because we don't have that yet, but we will in just a moment, because we are going to do that on the very next, almost the very next line. We're just going to do a while, and this is going to be a Boolean value that we are actually going to create. We have not made this yet. So while listening, of course that doesn't exist, so we're going to create ourselves a private field here. And this is going to be private bool. Technically, I like to explicitly declare that it's private. You don't have to, but I just like to. I think it's more clear. So we'll do that for the thread game as well. We're going to do a private pool. Pool? Apparently splash. This is a pool. No, this is a bool. And it's going to be just simply listening. And we're going to say that that starts off equal to false. Once we run the initialization function, we will set that here to be listening equals true. There we go. So we'll start up this thread. While listening, we are going to say var received equals await listen, like so. So there's our await call, so it's no longer throwing that warning, so that's good. And all that's going to do is it's going to, at the very first thing in the loop, it's going to wait until it hears something, and then it'll do something with that. So the first thing that we need to do is we need to determine if this, or rather we need to do some work with the session, because if this is a new session, then we're going to need to add it to our list of known sessions. If it's not, then we're going to need to work with it knowing what session it is. So we're going to first declare a session. That's not how you spell session at all. And we're just going to call this client session. Like that. We don't do anything with it right now, but we will in just a moment. So if sessions dot contains key received dot sender. So if we have a record of receiving a communication from this IP address and port, then this is something that we have already initialized. So we don't need to add it to the list, we just need to update it. So sessions received.sender.last message, so that we don't time them out, equals datetime.now. We don't need a parenthesis there, what am I doing? Okay. And then we just need to say client session equals sessions received.sender. And that's the reason why we are using a dictionary for this, by the way. The private dictionary here. We're using that so that we can just very quickly look it up via this key without having to iterate through the list in a kind of slow manner. So that's all we have to do there. But if this is a new session that we don't know about, we're going to need to do a little bit of work here to make sure that we know about it in the future. So client session would then be equal to a new session, so we need to create a new one, and this needs to be simply received.sender. And so we'll tie that to that IP address that they are connected to, IP address and port. Now, I would need to do some testing to see if we're going to have some issues with people connecting from behind the same router. If so, we might have to do a little bit of work on that, but I suspect that's not going to be the case because they should connect via a different port. It seems to choose a quasi-random port right now, and we may set a particular port and have some way to detect that. I don't know. The odds of it choosing the same port for two different instances is really low. So maybe we'll just ignore that for now, and if we run into issues, we can fix it later. So we'll just add that as a new client session, and then we'll say sessions.add, and then we will add in the client session.address as the key, and the value is, of course, going to be client session. Okay, so that just adds it to the dictionary. So there we go. We now have knowledge of whether this is a new client or not, and if it is a new client, we add it to the list. If it's not, we update the last message, and we set the client session to be the already extant session. Excellent. So the next thing that we need to do, of course, is we need to parse out what exactly is in this message. So that's easy enough to do. All we're going to do is we're going to put in a couple of variables here, and actually I think we're going to declare those variables out here rather than in the loop. And realistically, what does this return? Okay, fair enough. We'll just leave that. Let's declare the client session out here though. There we go. And then up here, we could say client session equals null. That might cause an issue. I don't think it will. If it does, I'll just mark it. Maybe an issue? I doubt it. Okay, so if it causes an issue, we can remove this and alter this. I just don't like to declare variables within loops because there's overhead for that, and we can just have the same variable declared outside of the loop, so that's fine. So we will declare 3 additional variables here. That's going to be int header length. We are going to have string header, and we are going to have string message. And those are all going to be just declared variables. We're not going to initialize those quite yet. What we are going to do, though, is we're going to initialize them now, after we've determined whether this is a new or existing session. So we are going to say header length equals received dot message dot index of, and that is going to be returning the index of the first comma within the actual message that is sent. So that'll determine our header length. We're kind of implementing our own protocol for these methods. We're not using anything like JSON or anything like that. This is just comma separated values, and it shouldn't be too difficult. So we're also going to need to know what the actual header is. So header equals received dot message, and then we're going to take the substring of that, which, funnily enough, IntelliSense already knew what I was doing. That's a little creepy, IntelliSense. Just saying. We're going to go from the first position, so index 0 here, and we are going to go to header length. And that'll give us a string containing just what our header is. So that's fantastic. And our header is essentially going to be an integer. And that's something that we will set up here in just a moment. So we'll come back to that. But first, we need to get the actual message. So string message equals essentially everything else in the string that isn't part of the header. So received.message.substring, and this is going to be from header length +1 just to the end, just like that. And we actually don't need to declare this. There we go. And now we just need a quick switch statement here, and this switch statement might actually get a little bit complex, so I'm going to create a function here, and we are going to call this process message. And this is simply going to take in a cast to message types, which we haven't declared yet, and we will declare pretty much immediately after we implement this. Actually, yeah, pretty much immediately after we make this line. int.parse header. So we need to convert the header back into an integer, and then cast that into an enumeration of message types. So let's go ahead and create ourselves a new item here, and this is going to be an enumeration. Visual Studio is going to call it a class, but it's not going to be a class. It's just going to be a public enum and a couple of other enums, actually. So we'll just call this comms enums. There we go. It'll be within this same namespace, but we're only going to put in the one enum for right now, and that's going to be public enum message types. Okay, so the first message type that we're going to implement here is going to be con. There we go. And this is going to be the connection initiation. And this is simply going to be, I'm just going to take this over a little bit, this is simply going to be a header, nothing else. Okay, so that's the only message type that we need for right now. We will need more message types, and we will handle more message types later on, but let's hop into the server here and implement this process message method. So let's just hop down to message processing. This is going to be public void process message, and this is going to simply be a message types message type. And this is just going to be a switch statement. I'm just moving it out of here to keep our main loop here a little bit cleaner, because this might get rather extensive later on, this switch statement. For right now, it's going to be pretty brief, but it's going to be expanded. So switch, and this is simply going to be message type. We're actually going to need to pass in a few other things here, of course. We're going to need to pass in the string message as well. We don't actually care about the... I don't know why I hit Control A there. We don't actually care about passing in the header length or the header. The header length is just used to split this up, and the header we're passing in the form of message type via this line here. We could do a try parse here, but we know for a fact, in theory, that this is going to be sending just an integer, so it should be fine. I've not had issues with it. Maybe... I guess we could say, maybe do a try catch here. There we go. But we're not going to do that for right now. So in this switch statement, the way a switch statement works is it's essentially just a fancy if-then series of statements. So we are simply going to do case message types.con break for right now. So if this message type is equal to messagetypes.con, then it will execute everything within here, which would currently just break it out of the switch statement. We're also going to do a default, and for now that's going to break, but we're going to want to output some sort of an error message here. And this is not a console application, so normally in C# I would just do console.writeLine, but console.writeLine doesn't work in a lot of these. At least it doesn't work in WinForms. I don't know if it works in WPF or not. We could test it, but what I know works, at least for our purposes right now, is system.diagnostics.debug.writeLine. And we are simply going to write in a string.format. And what is this going to say? Well, it's going to say... Let's see here. Received unhandled message. And then put in a parameter there, and that parameter will simply be message. Unhandled message type. Actually, this would be 0. Like this, and then this would be 1. So we would pass in the message types. So that would be what? System.enum.getName, I believe, returns the name of the constant. Yes. And then this would need to be type of... I can never remember the syntax for this. System.enum.getName type of message types message type. Like that. Now this is a little long. I'm going to go ahead and put that on another line so that you can see all of it on one line. About like that. Perfect. So that's just going to output received unhandled message type, and then this is going to be the message type name. So it would output either message types.con or just con. And then a colon, and then the actual message. So it'll just output a debug warning for us if we receive an unexpected message type. However, for the connection message type, all we're going to do first is we are going to do client session dot... Oh yeah, we do need to pass in the client session, don't we? That would help. Session, client session. There we go. Client session. Fantastic. Client session dot last message equals datetime dot now. There we go. We'll update that so that we don't time them out later on once we get the check for timeout done. Okay, and then we are going to say that we have made a connection at this point. We've made and stored a connection. So we should probably exchange public encryption keys. Now, this is going to require implementation of a send message, as well as another message type. So this message type is going to be message type key. And I'll do it like that. There we go. This is a public key for encryption. And the format that we're using for that is simply header XML key. Like so. Excellent. So, we're going to be sending a new message type, and we're going to need to implement a method for sending a message, which we have not done yet. We probably should. We're going to actually implement two of these, because there are two separate message types that we want to send, and that is a message with content and a message without content. So the first thing that we're going to implement is the message without content. So message that is header only. Public void send. This is going to be message types message type, and it is going to be sent to a particular IP endpoint. Excellent. So, how are we going to send that? That's actually super easy. All we're going to do is say var datagram, gam apparently, var datagram equals encoding.utf8.getBytes, and then we're going to format a string, so string.format, and this is simply going to be this. And then this is going to be int message type. Technically, I think I missed something here. Cannot convert. Oh. Hang on. Yeah, it's because we closed this parenthesis here. It needs to be closed here. There we go. That would help. So technically, I don't think we need the string.format here, but it's the same format that we're going to be using up, or rather, not really above, but below for the next send type. So we'll just leave it as is. If we run into issues, we can always fix it later. Pro tip, we won't fix it later. Just throwing that out there right now. So we're going to then, we have our message built, and now all we need to do is send it. And that's easy enough. So client.send. And all that's going to be is datagram, and then datagram.length, and also the endpoint that we're sending it to. Super easy. We're also going to implement another overload of this, which is going to be public void send. This one is going to be message types message type. This is going to also go to the same endpoint, but first we're going to do string content, then IP endpoint endpoint. Okay, so that overload will be used for sending messages that actually have some form of content in them, rather than simply a acknowledgement or a simple request of a particular type. So that is simply pretty much the same thing. Actually, we can just literally copy and paste this, which I'm going to do, like so. Except we are going to change here. There's going to be a comma in between this, and this is 0, 1. And the parameter here is then int message type content. That's it. That's all it takes. And that's our message sending done. We can minimize that. We do not need that anymore. We're not going to be touching that for a good long time. Okay, so the next thing that we of course need to do is we're not quite done with our init function here. Our message processing is reasonably done, except we should probably handle our new message type, which is message types.key. So we will do case message types.key. And all we need to do here is we also need to do client session.lastMessage equals datetime.now. Realistically, we should probably do this up here, because we need to do that for every single one of these. So we'll do that outside of the switch statement. We have not finished this yet. We need to send our public key to the client. So send message types.key. This is going to be the encryption manager.server RSA key. And we're sending this to client session.address. So we send them the public key so that they can communicate with us encrypted when necessary, which will not be all the time. Next up, we need to handle what actually happens when we receive a key. So this is actually, let's make a quick comment here. Con message requesting a connection. And then we'll make one here. This is a key message giving the server the client's public key for encryption. So we receive the public key here from the client when we're receiving a key type. So all we need to do for that is client session dot client RSA dot from XML string, and this is going to be just simply message. There we go. So we've handled that. We have a potential for an encrypted connection between our client and our server. Fantastic. So that's pretty much done. We're going to do a couple more things up here in the initialization function, but there's not really that much more. We're going to comment this one out. We're going to come back to this line, but GameManager.server equals this. That's going to be a static class that we'll come back to later. And in fact, all of this will be commented out. So in fact, maybe we should handle this when we are actually implementing the game manager. That'll be a little while. Yeah, we'll do that later. Okay, so we receive a connection here. That's fine. So when we're starting this up, this should already initialize up and should start us our server. So we should be able, at this point, in theory, to be able to connect. Right? Yeah, we definitely should be able to. So let's go ahead and pop open Unity and see if we can't get a connection. So first things first, we're going to go into the scripts folder. We're going to get rid of the simple camera controller script. We do not care about that. We'll also remove that from the main camera if the inspector catches up here. There we go. That took it a little while. We'll remove that. Fantastic. We'll create a folder here, and this is going to be netcode. And then we will call this the net manager. Excellent. And we'll open that up. That's going to open up in a new window of Visual Studio, and we're going to have to keep these straight. So this is the actual Unity project here. And let me pull open the already implemented Net Manager that I have. Apparently that Unity is taking a while to go as well. Fantastic. So we'll pull open the... Oh, this is actually the wrong project. I came so prepared. Okay. So let's open up Unity here. The Unity Hub. And we're going to open the channel MMO. Unity Hub? Are you okay? Unity Hub does not seem to want to open up the channel MMO. Because it's already open. I'm a moron. We were already working on it. Right here. Literally right here. The one that I wanted to open was not that one. So we'll open up Unity again. Because I am a complete and utter moron. Sudo MMO server we don't care about. That's one of the previous versions that I was working on. And that is now an unimportant file that I can probably delete, realistically. That was an implementation of this within Unity, because I was going to use the physics and collision detection of Unity, but we're gonna roll our own for that, for this project. It's going to be interesting, to be sure. So this is the file that we're aiming for here. We'll get there eventually. For right now, we don't care about that, and I'm just going to go into the netcode folder and pull open the Net Manager file, which will open Visual Studio on a different monitor, which is absolutely fine. And we'll open up the Net Manager here. And there's a few things that we're going to need here. So the first thing that we're going to need is some regions. So we're going to do region. Our first region that we're going to go with is references. And region. Okay, our second region that we're going to go with is private fields. End region. Okay, within private fields, we're going to need a couple. First off, actually, let's get rid of private in that, and we'll just call this fields. There we go. And we'll go with public bool should use localhost equals false. Okay. That's all we need to get started here, although we are going to need a client. So let me just open that file. Yes, that is in the connection manager file. So we will create a new C# script, connection manager. Fantastic. And this is mostly copy pasted from our UDP base in here. So if we go to the UDP base, let's see, where is UDP? Apparently I closed that. Yeah. So this is going to be basically the same thing. We're going to copy this struct into here. So we're going to put a public struct received here, and we don't actually need access to the raw message. We are, of course, going to need to use system.net, as well as using system.net.sockets. There we go. And then we're going to be bringing in basically the identical UDP base. This is the server here, so we're going to grab the abstract class here. And we're going to put that in right here. And then the client itself is not going to be a mono behavior. We're going to get rid of this. It's going to be called connectionmanager.cs, but it's kind of not going to be doing that. We are, of course, going to be using system.threading.tasks. There we go. And then we're also going to need system.text for the encoding here, using system.text. Excellent. Now we don't actually need this reference to the raw message, or this closing bracket. Excellent. And I believe, actually we do need this closing bracket. There we go. Excellent. We've still got a syntax error here where it's expecting a comma, and that's because we have an extra parenthesis. Okay. Otherwise, the UDP base is going to be literally exactly the same. However, we are going to have a slightly different client built off of that UDP base as opposed to the server. So we're going to do a class client of type UDP base. And in fact, we could just call this UDP instead of connection manager, and I'm going to do that. Just unify those names a little bit. Okay, there we go. Excellent. This is the net manager. Of course, I need to open this file. There we go. And we're just going to need a couple of functions here. There's a useless constructor that I have here that doesn't do anything, but we're going to need a public static client connect to string hostname int port. Point, apparently. Okay, so that will return a client. So var connection equals new client. Connection.client.connect hostname and port. Excellent. And then we'll just return that connection. So that's how we're going to spawn our client, is with that static function. And then we need a couple of send messages. So public void send. And these are going to be literally the exact same as we did for the server. So in the server.cs, we're going to grab these right out of here. I'm going to copy the whole region here, because this is literally the exact same. Well, almost literally the exact same. We're going to make a couple of minor changes to them, but we'll just paste that in here. We're not going to be putting in an IP endpoint. So all we need is string message types, or rather message types message type, and string message. Of course, we're going to have to import in our message types, but that's fine. We are not going to be sending an endpoint because it's always going to be connecting to the same endpoint, the server. So we're going to get rid of that, but instead of this being string content, this is going to be a byte array of the message. And that's so that we can send our encrypted messages just a little bit better. This would, of course, be... In fact, this is our encrypted message, so this one's going to be a bit different. We'll implement that right now. So this is going to be a byte header equals encoding.utf8.getBytes string.format. This is pretty much exactly the same as up above, where we're just doing this with a header int message type. And of course, we don't know what message types are in this project, and we will just copy and paste that in a moment. I think I missed a parenthesis. Yeah, I believe that's what that was. Maybe. Still expecting another parenthesis? No, it should just be this. Clearly I typoed something. Or maybe it's freaking out because of the message types. I'll just paste that in. Okay, I did typo something. This is the correct one. Oh, I think I missed this comma or something. Okay, so now we're going to need to make our datagram. So byte datagram equals new, this is a byte array, and the length of this is going to be header.length plus message.length. There we go. And then simply we are going to do some block copying here. So system.buffer.block copy. And we're going to copy in the header 0 datagram 0 header.length. Excellent. And we're going to do one more. System.buffer.block copy, and we're going to copy in message 0 for the offset, and then datagram header.length for that offset, and message.length. And then we are going to do client.send, which is not this one, but this one, now that we have this structured correctly with the byte array. Datagram datagram.length. Excellent. So that's good to go. We now need, of course, our message types here. So we'll create a new C# script, and we're going to call that comms enums, as we did before. This is not going to have a mono behavior in it. And all we're going to do is we are going to, if I go to the server, all we're going to do is we're going to copy in this enum for right now. We're going to have to make sure that these stay exactly the same. But I'm not going to automate that. We're just going to do that. Excellent. So that is actually our client completely done. So now we can hop into the net manager. And there's just a couple of things that we need to do. We're going to get rid of void update for right now. And in the start, all we have to do is if not should use localhost. So if we're not supposed to use a localhost, then we want to do client equals... hang on. Why is that capitalized? It should not be capitalized. Oh, of course, we're going to have to make a client. Private client client. There we go, that would help. Client equals client.connect to. For right now, we're going to say some hostname.com port. We don't have any external connection to connect to. Of course, we are going to need a private constant here. Private const int port equals 4315, because that's the one I arbitrarily chose, and we'll make this all caps because it's const. Fantastic. Okay, so that's if we should not use localhost. Obviously, right now we should use localhost. So, else we need to do client equals client.connect to, and this is going to be 127.0.0.1. We could also use localhost there, and the port. And we will simply init connection. And we also want to make sure that we don't destroy this on load. This .gameObject. Now, we haven't implemented init connection yet. So we'll do that real quick. That's a pretty simple thing to do. So public void init connection. And this is just going to create a task from the factory, much like we did in the server. Task.factory.startNew. Another async task. And if I can find the equal button, there we go. It tends to help. And then we'll just do that. And then we'll need a semicolon at the end. Fantastic. So we're going to put in another field here. This is going to be private bool connected. We may need to make that public later on, but for now, we'll leave it as private. And we are going to say, while connected, we want to try var received equals await client.receive. Now, of course, client doesn't have a definition for receive right now. We're going to need to implement that. And received is going to be of what type? netmanager.client. Right. Okay, so we're going to need to get that receive function built in. And that is actually out of the UDP base. And we actually have that. I just renamed it to listen for the server, which is fine. We'll just call this client.listen. Fantastic. No worries there. Don't have to implement anything at all. The other thing that we want to do within this try is parse message received.message. Okay. We haven't implemented that, of course. That's fine. Message does not exist. We will come back to that. We need to do catch exception E. So if we have an error here, we'll just catch that, and we will, for right now, we will... Actually, what I'm going to do is I'm going to just do what I did previously, but within a comment block. It's not going to work exactly as is right now, but I want to add a job to the job queue, which we will implement later on. And this job is going to be something like this. UIManager.showModal server connection interrupted. Please check your connection. Okay, we'll just leave it like that for now. And then we will say connected equals false. And debug.log error E. Now, debug.log error E is something that we will actually do here. And we definitely want to close this block for the block comment. There we go. And we'll actually debug log that error. I spelled exception wrong, didn't I? What are we missing here? We just need to use system. Easy enough. Okay, so that's pretty much all we have to do here, except after the add job, we will break out of the while loop. So that's fine. And then as soon as we are out of the while loop, I just want to debug.log client thread ended. Okay. And then at the end here, after we have after we've set up the task, this is outside of the task, we want to do client.send message types.con. And no message. Okay. So that should be fine. Of course, we need to implement parse message. We're not really going to implement this right now, though. So we are just going to come down here. This is... Yeah, that's right. So right down here, we're just going to do a public void parse message string message. But we're not gonna actually do that just yet. So receive.message is something that we are missing. It's here in the struct. Why is it saying that we don't have one? Oh, it's because it's lowercase m. I am a moron. Okay. Good to know. So that should be our net manager pretty well good to go. Realistically. So let's create ourselves an empty here. And we will name that net manager. And we'll put in the net manager mono behavior object. We should use localhost for right now. And let's see if this works. We'll start up our server. This is not the server. This is the client. We'll start up our server. See if we have any errors. There are build errors. No. What's our error? Syntax error over here? Oh, yeah, of course. This would be a syntax error. We do that, and then we have this, which means that we need to get rid of this parenthesis. Okay, no more errors. Let's launch this. Okay, it looks like we are up. In theory, we should have our listening open, although I don't believe I'm outputting anything here. We'll see. And let's just see if we connect. Client thread ended instantly. What happened here? Client thread should not have ended that quickly. That's problematic. And let's see here. Just checking output. Here we go. Okay, so no output from the server. Why did the client thread instantly end? Let's see what we can find here. Init connection, so we do this. This is within the task factory. Oh, it's because we don't have connected equal to true. Connected equals true. There we go. That would help. Client thread ended. Ah, existing connection was forcibly closed by the remote host. Okay, that's good to know. So, we're connecting to 127.0.0.1, and this should be on port 4315, and that's correct over here, right? Let's see, that should be in server.cs. IP endpoint is here. What port are we listening on? Where do we create that? We are supposed to be listening. Listening equals true. Do we ever actually initialize that? Hang on a moment. Let's take a quick look here. I believe I may have forgotten to properly initialize that. Let's see. Yeah, that's supposed to be in the constructor of the server, so that's here. Listen on equals endpoint. And we put in the endpoint there. So that's supposed to be in here. So we are... Aha. So we're not actually creating any of this. It would help if we did. So the server is just a class, so server equals new server, and we want the IP endpoint to be IP address dot parse. We want to IP parse 127.0.0.1, and we want the actually, hang on. Read-only span char IP string. How did I do this previously? I don't even remember. Let me check. I've completely forgotten. Let's see. It's in here. And then we do server equals new server with no arguments. Ah, right. That's how I did it previously. Okay, so server equals new server with no arguments. And then we say server.init, like that. But, of course, we need to implement that constructor with no arguments. So, we will implement that over here. And this is super simple. Public server, this new IP endpoint, IP address dot any, and then port. But the port we're going to use is 4315. And there we go. That's the entirety of the constructor. Excellent. Okay, so we'll run that and see if we have any errors. Looks like we do not. Let's see if we can connect here. Looks like we did. Now, we don't currently have any output to verify that. Exception thrown. Argument out of range exception. Where was that? I'm guessing it was in here? Maybe. Let's actually get rid of this and see if that fixes it. I doubt it will, but we'll see. I also want to make sure that when we receive a con message, let's simply system.diagnostics.debug.writeLine, and this is just going to say received connection from 0, and this is going to be client session dot address. Okay, so now in theory, we should see that actually be output here. No exception there so far. Okay, Unity did not output anything. Exception thrown. Argument out of range exception. Why is that not causing an actual error? We must be catching it somewhere, but we're not doing any tries in the server. Where's that error being handled? We're definitely connecting in here. Let's see. Sessions equals new dictionary. Yeah, that's fine. This should... I mean, it is working, right? We know that it's connecting, but we're getting an error. I believe it's with our dictionary. is my guess here. We'll see. I'm not sure why that's not, or why that's throwing an error. Exception thrown. So why is that not actually stopping when it reaches that exception? Because we're not handling the exception, right? I don't think we are. Yeah, we're not catching anything. It's exciting. You know what we could do? We could place a debug output here before we get this. Client session has not been set here. But instead we can do receive.sender. Like that. So if the problem is indeed here, we should see that this output happens first. Okay, so there's our connection. Received connection from 127.0.0.1 with a random port, as expected. Okay, so that's great. So I'm going to do a little bit of troubleshooting here to see what this argument out of range exception that's being thrown is, but that's going to happen off camera. And once I have that figured out, I will come back. But we have achieved my goal for this episode, which is simply to get a simple connection between the two programs. So that is fantastic. For now, though, you can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time.